Hey there, thanks for joining us at the Rabbit Hole of Research, where you'll learn a few facts that you can impress your friends with at a party.
Hey, welcome back to the Rabbit Hole of Research down here in the basement studio. We're all crewed up. You've got me, Joe.
You got Nick.
We've got Nick.
Georgia.
We've got Georgia.
You got Mary.
And we still have Mary leaning way back from the microphone. So.
But the good news is she came back.
I came back. I knocked on the door and you let me in. So
we did, yeah.
Sorry about that.
There was a little hesitation there.
Yeah, it'll probably seem like a bigger gap because I think there's some episodes in between where
Right.
Nevertheless, that's all the podcast magic. We also do have a guest with us because today, pretty excited to talk about this topic, planetary defense, saving Earth from otherworldly impact. And so,
hi, Charles Blue. I am actually a science writer by, I won't say training. I don't know if you can ever be fully trained for that, but I've been doing it now for about 35 years in some way, shape, or form. Much of it in astrophysics, engineering, a little bit of biophysics, and most recently for 3 years at NASA. And I just have a little stint in the Science Mission Directorate, which includes the Planetary Defense Coordination Office, PDCO. Mm-hmm. And if you want to hear, the coolest job title in the world is Planetary Defense Officer. I love the fact that somebody at NASA has that title. So yeah, I worked with the team for a while. Got to help out with one of something called a tabletop exercise, which is when they sort of do the what if scenarios of a potentially hazardous object that is going to get way too close, like actually enter the atmosphere, and how that would be responded to. So I had the pleasure of learning about it, talking to these people, and I'm happy to give you the information I know, but I do have to say I'm speaking as myself, as a independent citizen who just happens to be a bit of a duffer on topics, and anything I say beyond what is referenced in my publicly available resume is purely speculation on my part. So I'm not speaking on behalf of any organization. I'm delighted to talk about a really cool topic.
I think this is the first time we have had a disclaimer like that.
I know, yeah. It's like,
it's like you can't.
You know what? We should have a disclaimer like that.
I feel like I should disclaim myself too. I don't know. It's like I'm not speaking for any. No, yeah.
No, that
very good. No.
I've had some people that I've worked with get in trouble for not saying.
Oh,
that,
really?
So,
wow. There it is. We're stepping up here.
Yeah.
To get going, I have my open if you guys like. So,
what if we said no?
I don't know. I offered it up as an option, but I feel like I should. I feel like that's as good host.
That's kind of like when we're in the story time and we go, do you guys want to do this again? And then there's that one kid that goes, no.
Yeah. See? You're
normally me.
Sorry.
Cool. Or is it done? Are we done? Okay. All right. But I know scientists being very scrupulous. You want to make sure that you don't talk out of turn and make it clear that, well, not necessarily your opinion, but it's going to be fun to talk about, especially because I want to hear about all the cool near misses that we haven't heard about. You're going to tell us about those, right?
But first, we have to let Joe do his opening.
But he gave us the option not to, so we said no,
it wasn't
right?
An option.
Oh, no. Okay, darn it.
You're supposed to nod and say yes.
I'm fired again.
It.
Okay.
Yeah, I mean, come on here. You're showing me up. All right, I'm just going to go.
Okay.
Somewhere out there in space, there is a rock on a collision course with Earth. It's happened before, and Earth has the scars to prove it. 66 million years ago, something came out of the sky and ended the age of the dinosaurs. 115 years ago, something exploded over a remote Siberian forest with the force of 1,000 Hiroshima bombs. And in 2013, while scientists were busy tracking a completely different asteroid, doing a close flyby, a rock nobody had seen coming emerged over a town in Russia and put 1,500 people in the hospital, mostly from broken glass. We got lucky. We kept getting lucky. But luck isn't a plan. To have a plan, we need to see it coming. Whoever sees it would have to decide whether to tell anyone. Countries with the technology to act would have to agree on what to do. And once the plan is in action, hope that our best intentions don't accidentally make things worse. NASA has proven it can actually move one, and Hollywood makes saving Earth look easy. But what would really happen when the universe stops missing and we have to rely on more than hand-wavium to save us from Armageddon?
Oh, nice.
Damn.
That's a great lead in.
Very good.
I'm so glad we didn't skip it.
I think it was fine.
Yeah.
I don't know how I can possibly improve on that. So
Okay.
Oh.
No, yeah. So, I mean, I think I'll throw it to you, Charles, just to maybe to expand on it and maybe give what would we be defending ourselves from? What should we? Well, there's a lot of terms out there: asteroids, meteors, comets. Can you set
Alien
that
ships.
stage? Alien ships, yeah.
Yeah.
Yep.
I heard
So-
alien
Yeah,
shit.
well-
You know?
Let's start with the actual factual.
Hey,
then
listen,
we'll
we
get
got
into
somebody from
alien ships.
NASA here. All right. All right.
What's in Area 51? That's
We're gonna
what
go
we wanna
right.
know.
We're gonna
Yeah.
go right there. Okay.
the same thing that's in the basement of the Alamo.
Yes.
Pee-wee's Pipe.
Please, Charles.
But that's a great question. Because, that's one of the things that people who are in the planetary defense community are very careful to say. We're not looking at comets and asteroids. We're looking for potentially hazardous near-Earth objects, NEOs. So they could be things like they could be an asteroid. These things could be metallic, really hard, dense. They could be carbonaceous. They could be any of the mixes that you can get that form the asteroids that are out there in the solar system, or maybe from a different solar system. But also we have these comets, which are essentially dirty snowballs. They can come from far out in beyond the Kuiper Belt, out in the Oort cloud. And unlike some of the comets that have these regular periods like Halley's Comet, these things could be, they've never been here before. So how soon we detect them is really an important question. So really, if it's anything that's out there that is somehow going to make its way into the inner solar system, the idea is to find it, catalog it, track it, and see, is there even a remote chance? And I will say, the reason that I can get to sleep at night is knowing that as far out as calculations go, which is about 100 years, there's really nothing that has been discovered and cataloged that poses a risk. Certainly there are smaller things, but we're talking about something that's, say, up to a kilometer, which will give Earth a really bad day if it were to enter the atmosphere. But currently, at least for the people in the planetary defense community, they don't go to sleep and feel like, gosh, I hope I don't get smacked tonight by an asteroid.
So, I mean, you mentioned something interesting, and that was size. So you said that a kilometer wide, we got it, they're all tracked. There are things smaller. So should we worry about those smaller things that could slip through or appear too late? And we'll probably get into some of our defense mechanisms that we can use, but is that something?
Yeah. Well, you mentioned the Chelyabinsk asteroid. This is one that blew up over Chelyabinsk, Siberia.
Yep.
There really wasn't a considerable amount of warning on this. We're talking the order of hours that something was being tracked. And when this thing exploded in the atmosphere, you mentioned how powerful it was. And yes, people got injured. That's because there was this massive bright flash in the sky. So what's the first thing people do? Well, they go look out the window.
Yep.
So they're putting their face right up to the window, and then there comes the pressure wave, and suddenly you got glass flying everywhere. So when you see a bright flash, I think it's pretty cool, but get away from the window. There are things of all sizes, and the Earth is constantly accumulating dust-sized grains. Tons of it per day is actually running into Earth, or Earth is running into it as it goes around. So it's a constant stream, and you can get things from the size of a sand grain to something the size of what was on The Simpsons, the head of a chihuahua, to things that are much bigger. But when you're talking about things that are like up to the size of, let's just say 100 yards, you're talking about something that would really be dangerous to something on the order of a city.
Right.
So yeah, and those things are obviously harder to find. The bigger they are, the easier they are to spot. So you run everything from, yes, you're going to have a bad day in this localized region, to it's going to be a bad day on a seaboard, or it's going to be a bad day for everybody on the northern hemisphere, depending on the size.
And
So,
that's how.
If you guys notice something coming, do you give that area that you think it's going to hit warning, or is it just like We'll see how they turn out.
Mercifully, that hasn't been an issue. So it hasn't happened. But the idea is that keeping things quiet is not, it's impossible because it's not one group, it's not one organization. This is a global network. The data are instantly uploaded to
And they're all working together?
databases. It's a really great community of researchers and observers who try and like keep that flow of information going, because obviously as Earth turns, you're not going to be looking in one direction. You want to have other telescopes around the globe being able to track and study this thing. And also we've got detections being made by satellites in space, by other ground-based observatories. So it's not something that you're going to be able to keep quiet. It's not like what was it Deep Impact or the other one?
Armageddon. Yeah.
Armageddon.
Armageddon.
So there's no hiding it because it's not one government or one agency that's tracking these things.
Yeah. I mean, but that gets into, though, when do you tell the public? Because if something, let's imagine something's coming or you think something's coming, the headlines could get really sensational. And then it's not, was it Apophis? I think that was the one that it was like, oh, this might hit Earth. And then people freaked out. It's kind of big splashy headlines. And then really more refined calculations. It was like, no, it'll get close, but we're in pretty much zero danger of anything happening. And so you have this kind of cry wolf moment where if it happens too many times and people, I guess it's not happening all the time, but people, they don't pay attention to it. And should they? Maybe it's like kind of one of those things. And
there's panic.
Right. Or panic, that could happen too. So is there
this is a great transition into a little exercise that NASA and other organizations do every 2 years or about every 2 years. And this is called the tabletop exercise, which is you get all the invested parties. This is from various government agencies, different science organizations from other countries into a room and you say, okay, here's the scenario, guys. We've got this object and we discover it and we're observing it and we get some initial data just as it goes behind the sun and we lose it. We know we're going to be able to see it again, but it's gone. But from that initial observations, there's a 10% chance that it might hit Earth. And this is an exercise, hypothetical, none of this stuff exists, but it helps people say, okay, what are we going to do? And that's interesting data. So yeah, that would not be withheld. There would be.
So what's the time span that they would have? Like in that scenario?
In that scenario, it was a multiple year time span. So there was enough time to say, okay, we're going to wait till we can actually get telescopes on it again, see where it's at. And then this cone of uncertainty of what might happen gets clearer and clearer until finally you say, okay, the chance of entering into Earth's atmosphere is getting a bit stronger. That's when you also have to say, okay, now what do we do about it? Is this big enough that it's going to be global catastrophe? Is it something that might be a danger to a small area? And what you really want to be able to do is say, okay, well, it's going to hit the Earth. Most of Earth's surface is water.
Right.
And so if this thing is on the order of a kilometer, you could get some tsunami and coastal problems from it, but it's not going to be a major danger, like something is going to be hitting like, what's the last tabletop exercise, you saw this potential cone of it going across the east coast of the United States, and it was right in the middle of it was Washington, D.C. And I'm like, I wonder if they planned it that way. No, that was just kind of random, like the way the ice fell. But I was like, wow.
Yeah.
Let them crash.
That's right, yeah.
Some daydreaming happening.
You can cross your fingers and hope.
But that's
a lot of the planning is how do we better track what it's doing? And that could be by launching something that is many of the other planetary missions from NASA is like, okay, let's get up close to a comet. Let's get up close to an asteroid. We've got the Psyche mission that's hitting out to that asteroid. But do you have enough time to do it?
Speaking of Washington, D.C., like I know that there has been cutbacks like with weather, people analyzing weather in different organizations and departments. I mean, is there any chance that this department will
cuts to NASA. I mean, I think that budgets have been hit all over. I don't know.
Yeah. No pun intended.
Yeah.
No pun intended. But yeah, so.
I don't know.
Well, it's, that's a tough thing to say. I mean, at the moment, fortunately, this is not, again, just NASA. It's a multinational program. But NASA does have a really strong role to play in it, partly because of the instruments it can bring to bear. There's really some wonderful ground-based research, but this is also National Science Foundation as well.
Yep, that's right.
The 4-meter dark energy camera at Cerro Tololo in Chile is perfectly designed to look for these dark, distant objects. My favorite one is it found a very distant planet-like body out past Pluto that they nicknamed Didi, distant dwarf. I just thought that was a cool name. But it can also, these things are also really good at looking at stuff that are coming from like the sun side. So when you have that really narrow time frame where you can actually look for those near-Earth objects inside the orbit of Earth, inside the orbit of Venus, which are really hard to spot. Something like the Blanco telescope in Chile is good at that. And also space observations. Hubble does it from its data, not directly looking for them, but the signals are in the data. And there's also a new mission that I believe is supposed to be launching in the next year or two that is specially designed to look for these things and study them, because it's been a...
So Charles, can you
go ahead. I'm sorry.
The kind of strike that happened, the explosion in 2013, it was missed because it did come from the sun side, and that's why. So can you maybe expand on that? What's the difficulty of seeing something coming from the sun side?
I mean, haven't you ever tried to drive and that sun's hitting you? It's hard.
I put my hand up. Can we do that? Just like the space hand, we go there? No. So, because you would imagine things would be... Yeah, go ahead.
You would think then it's like, oh, it's all bright and clear. We should be able to see this. No problem. Well, actually, no, because pointing a telescope in the direction of the sun is kind of defeats the purpose.
Yeah, right. You just wash out the detector is kind of it. Yeah. Okay.
Right. And it just makes it a very difficult thing to do. Yeah. In the tabletop exercise, the idea was, we're like so many things, you've got orbital dynamics. Sometimes they're visible. Sometimes they go on the other side of the sun. So you have to kind of wait for it to come around. That particular, now I've just pulled it up, but the exercise was looking at an asteroid that had a 72% chance of hitting Earth in approximately 14 years. And that's a nice lead time.
Right.
But on the other hand, that's only 14 years. So we have to know what to do about it. And it's a question of who's going to take the lead, how fast do we have to launch, how long will it take orbital dynamics to get to this thing?
Yeah, if you're doing dark... I was going
to ask, what are some of the ways you...
Can I ask one thing before that? I think that's good. What should we do? But I think one of the things you mentioned was that, let's say it's going to smash into the ocean, 72%, it's going to hit the ocean. This is going to be some tsunamis. Oh, these 12 countries no one cares about, I'm just saying, geopolitically, they might be, I'm not saying I don't care, but I'm just saying that when you now have to go and say, well, let's now send rockets, let's launch things to and we'll get to George's question, like the things we can do. If you're in a country with the technology and it's not going to affect you, do you have any, is that talked about? Like, oh, we feel we should spend tax dollars to do X or Y. Is that a consideration, or does it come up in these tabletop kind of scenarios, or?
Well, to make the estimate of where it might actually hit on Earth, if you're waiting to find that out, it's too late to launch a mission. So, like, if you discover, we finally got the calculations, yes, it's going to land directly in East Podunk, some city in the center of the United States. Well, by the time you know that, there's no chance of doing anything about it. So at that point, it becomes the issue of how do you handle things from... It used to be FEMA. We don't know what anymore to deal with it. But what can you do to do that?
Well, I'm saying if this was going to hit somewhere that isn't...
Are you saying you kind of do a cost-effective...
Yeah, right. So if it's not U.S., it's not a U.S. territory, it's,
but like you said, this is not just U.S., this is...
Right, but if it's going to hit the ocean, that's that scenario. Like you've kind of now, it's going to come in 12 years. You'd think it's going to hit somewhere in the Pacific. There's not a lot out there, but it might cause a tsunami that then rolls, or is that still taking too much of a chance? Like you better do something.
It would be far too difficult to figure out where it might strike Earth at that point. And again, with 72% chance, that little bit of it, that 28% uncertainty, there's so much that you just can't calculate as far as where on Earth. So if you're waiting to find out if it's really going to be a risk to your country before you send anything up, it's too late. So the idea is you would have to marshal resources. You have to make the decision what to do well in advance of really knowing where it is. And it's 72% chance of something big hitting Earth. Yeah, I think you want to
do it. So you probably would. And hopefully you have political cooperation, right? And that gets into George's question of what options are available, what can be done, right?
Right, like we shoot it out, or do we get
like the dart,
or do we get like a group of old retired men to?
Where are we going?
To
Armageddon.
Or do we get a bunch of trash and then shoot that rocket of trash to deflect it?
Use missiles.
Futurama? No.
I think a giant slingshot.
That's right.
Awesome. Wonderful thing about this, particularly if you've got years, the angle of deflection that needs to be done is so incredibly small compared to what you would need to do if it were a month out. So really, there's several things you can do, but some of them can be fairly, seemingly not all that impressive. If it were something that is going to be doing a couple of orbits that gets close to the Earth and eventually starts to zero in on it. Well, you know what? If you just paint one side of it a little brighter, then that extra albedo would give it just a little bit of push it right out of the way. If it's something, though, that you really need to give a push to. If we were saying we don't have that much time, but we have enough time to marshal something. Yeah, you were mentioning this, the DART impact. And this was a kinetic impactor. It was basically, let's hurl something really hard at it and see what happens. And this was done by an asteroid that actually had another, like a moon. This was, the asteroid moonlet was Dimorphos. And the idea was just to hit that and see if it changed the orbit, and it did. It was a brilliant success. And to your listeners, you can actually see the video of this thing getting closer and this little dot getting bigger, and suddenly no signal. And then you hear everybody in control room just cheering. It's like cheering for losing the signal? No, precisely. And there's been some really intense reviews of what happened. Both ESA is sending a probe there to get a really close look at it. To ESA, the European Space Agency, is sending a probe. They're going to be able to see really kind of what happened to it. Some of the debris that came off of it, well, it's possible some of that's going to be hitting Mars, but it's not like it's a risk anything on Mars, because this is considerably smaller than the stuff Mars normally gets pummeled with. But the thing is, you've got a test case of one, which is
really nice, right?
So much better than zero.
Right.
And the technology works. And if we needed to have it, getting something up there that is just sheer force hitting it, nothing that sophisticated about hitting something with a spaceship. We've done that unintentionally a fair few times in the past.
Yeah, you have that. I mean, I was going to say the other is like conventional nuclear weapons that you see that portrayed in Hollywood. I know there's risk of putting it into, one is to put it into the actual asteroid and then detonate, and the other is to get it close and detonate. One's probably a better idea than the other.
Are these plausible options?
Are these just hand
it looks like they're considered, but I don't know.
They have been considered, and it certainly is a viable option if it's necessary. I mean, if you don't have enough time to get an impactor up there, and you need more than like the force of a VW bug hitting a hunk of rock. You need something that's going to be a nuclear blast. Yeah,
what would the size difference be? Would it be, at this size range, we can use the VW bug. At this size range, we need to hit it with something considerably larger. Is that part of the consideration, or is it?
That's that's absolutely part of the consideration. Another is, what is this thing made out of? It's one of the reasons why when they're doing the table exercise, it's like, yeah, we can like send up all these things. We can send up an impactor, and maybe if it's necessary, we'll put a warhead on it. But we don't know what it's made out of. So there was a sample that came back from the asteroid Bennu. Bennu is just a rubble pile. It is fluffy. It's loosely compacted. When the OSIRIS-REx mission actually just grabbed a hold of a hunk of it to bring it back, so much was blown off the surface, and they realized this is a real loose collection of rubble.
Right.
Well, you hit that with an impactor, it's probably going to blow apart. You hit it with a nuke, maybe that will have something different. So you have to figure out what this thing is. If it's pure iron, that's different than something that's rocky as well. So getting a mission there first to look at it, it's like, oh, okay, we couldn't tell this from Earth. Now this thing is this type of object. Yeah, that is really important to know. I mean, if it's mostly ice, maybe an impactor is not going to be the most effective thing. Maybe you need something like the heat from a nuclear blast to melt a bit of the side of it so it changes its trajectory. But again, so much of what you need to do is based on how much time you have. The more time, the more options.
And that's what I was going to say. The nuclear option, we do have isn't a nuclear space treaty. They're not allowed to actually have nuclear weapons in space. So to use this option, you would have to come to some geopolitical discussion, or you have a secret nuclear platform that was in the movie Meteor, I think.
Meteor. Yeah. I actually got stuck in the front row of that when it played in my hometown. Tilting my head up, I was like, I had a headache for a week. But yes, if you haven't seen Meteor, it's actually an excellent sort of first deep impact Armageddon type movie.
Yeah, I was just watching it just a little bit ago.
Yeah.
And and I came up and I was like, oh, look at that. This came out.
When did that come out? Like, it would have been like late 70s?
Yeah, it was 79, I believe. It had Sean Connery and Henry Fonda. Sean Connery was the scientist and Henry Fonda was the president.
I can't see Sean Connery as a scientist. Like, I look at that man and I don't go, he's a scientist.
Is that because you're thinking of like Zardos?
If you can see him in Zardos, you can see him in anything.
Yes.
What were you going to say, Mary?
I was just good. Yeah, I thought it was like a fun little side rabbit hole, yeah. No, definitely not. But in like media depictions, are there any favorite media depictions that you have besides Meteor that you enjoy, even if they're not?
Say, I loved Don't Look Up.
Oh, I was gonna say,
it wasn't about the asteroid. It was about
right.
Oh, that was so good.
Yeah.
But again, the end result of it was like sitting there having dinner, having a toast, and suddenly vaporized. Like, that's probably pretty close to it.
Right. And just everybody's reaction and their attitudes. It was so appropriate.
How it goes.
Like,
all right. I've got a very important question.
Yes. You have a list? I do.
I don't want the list. No.
That's not his question.
Not even close. If you guys discover that there is some kind of life form on the meteor or whatever.
Oh my God. Or if it's like some sort of like technology that came from another solar system is passing through. That would be cool. I would love to have that problem.
Is this just something you can't disclose?
Or maybe it's like, how big is that organism? If it's just like a little teeny tiny organism.
Or what if it's dumb?
Well, something, Charles, you might not know, but we're all obsessed with the movie The Thing. So this probably, features a lot into why we're asking you about these things. About creatures from
a movie that tanked at the box office, that has legs. It is so good.
Yes.
It is.
Oh, it wasn't understood at the time. I think people thought it was one thing, and it came out, and it was.
Are we 5 for 5 for The Thing? 10 out of 10.
Better be.
Yeah.
I don't
there we go.
Excellent. This will be he's just going to turn it off.
There's a bust of John Carpenter here, so it's that's
not to mention your thing.
And the Thing, so it's
the little golden book. Yeah.
Just
ish.
Joe tried to model his life that way.
Mm-hmm. I could take a little bit of a digression on that, and I did mention the asteroid Bennu and the samples that came back from OSIRIS-REx. As people are analyzing this, it really is incredible how many organic molecules, complex organic molecules have been detected in this sample. And I'm not the first to propose it or think about it, but the parent body of this thing was likely out in the distant solar system 4 billion years ago, had a lot of radioactive material in it, so it was able to have some semi-liquid water. And the fact that these things like all the bases, nuclear bases of DNA, adenine, guanine, thymine, cytosine, were all detected in this.
Wow.
So it's, and also it was shown that it was in this aqueous environment. It had some other elements to it that suggests that it could have been packed with organic type molecules. Wouldn't it have been interesting that the planet, the original body, had enough water and heat that it may have produced life? And that's a real speculative thing to say, but it is interesting how much the universe really wants to create the building blocks of life, and to find it in that just shows that who knows what type of life
that adds to
Can I say?
well, you go ahead.
Would that be an extreme of
But I was gonna say, that is the one theory of panspermia, right? Is that the building blocks of life actually originated extraterrestrially and arrived on Earth through meteor strikes, bringing organic material into Earth, and then that was the spark that led to more complex organic RNA world, the RNA soup kind of theory, and then what we consider modern life. So finding some of these samples now adds a little more credibility to these theories of the start of life and how that could have been much more universal. And if it can happen here and in other planets with similar the Goldilocks zone, it might also
and
then
you don't even need a
that,
Goldilocks zone so much. I mean, if you've got something like Enceladus or Europa, which have subsurface oceans, maybe that is certainly wouldn't have looked at it as Goldilocks zone. And we've got Mars and Venus technically in the Goldilocks zone.
That's right.
Great place to be. And if you go back a little bit further, we're talking about asteroid impact. Back during the Hadean period, this is very early in Earth's history. It could have been that there were some, life existing there, and then it got completely wiped out. So the impact that created the moon, that was a situation where it would have sterilized the planet.
Right.
But to really to make a nurturing environment at the time, it required massive asteroid impacts, perhaps, to keep this reducing environment. Quote, reducing it, it's good for certain chemistry to create organic molecules. And it was quite likely that Earth's atmosphere was only mildly reducing, only mildly good at creating complex organic molecules until it gets smacked by some really large asteroids during this heavy bombardment in the early history of Earth. Not enough to sterilize it, but to keep re-energizing Earth's atmosphere. So this thought that we need to be wary of asteroid impacts, yes, absolutely. But we should also be kind of grateful for them in a way, because that may have helped to kickstart life on Earth in the first place.
Well, probably led to us talking on this podcast, because if the dinosaurs get wiped out, mammals may not be the dominant species on Earth. If we are,
that might have been the better thing for Earth, but not for us in the podcast.
Yes, yeah.
Here's a little bit of a science writer history in my part, and that is back in the day, back when I was kind of a wet behind the ears science writer, I was working for the American Geophysical Union, and we had this little press conference about the detection of a impact in the Chicxulub area, essentially the smoking gun, the impact from the asteroid that was the end of the dinosaurs. And that was really a bad day for a lot of reasons, because if it had not hit that area, if it had either landed on land or if it went into the ocean, the deep ocean, it would have wiped out a phenomenal amount of life. But it may not have been the end of the dinosaurs, because this thing hit in this limestone area that was not too deep underwater. So it vaporized this. It created an amazing amount of just toxic chemicals that also went up into the atmosphere. So it wasn't just the initial impact. It was, now we've got an atmosphere that's chock full of sulfur particles and the materials that were thrown up from hitting this particular type of rock. So it was really a unique set of circumstances. 5 seconds later, when the Earth would have turned and it came down elsewhere, there still might be velociraptors running around Chicago.
Wow.
Well, we wouldn't be around, but
right. That area, was that the Gulf of Mexico area? Is that?
It's off the Yucatan Peninsula.
Okay.
Yes.
Okay.
And actually it was discovered before it was sort of announced at science conferences, because the oil companies that were drilling for it go, well, we've got all these fractured rocks here. Yeah, it looks like this big type, like something was there, but we don't care. No oil, so we're going to go somewhere else.
Oh, wow.
Yeah. There you go. Got to make that money.
I mean,
Listening. I wanted to ask about. Go ahead.
Oh, go ahead.
Well, I wanted to backtrack a little bit because, yeah, exactly. Beep, beep. You were talking about something called the Oort cloud, and I just for folks, what is the Oort cloud?
There's a lot more to this solar system than you can possibly imagine, but this is kind of like the very outer edges of what would kind of be the solar system. And we're talking about a light year away. So this is really out there, but beyond Neptune and beyond the other like icy bodies like Pluto and Eris and all the rest of things that are out there that are big icy things, small icy things, there is this distant area where some of the comets that we observe are. And we see this around like protoplanetary disks. The observations from the ALMA telescope and others that are seeing really young forming solar system see these same things as well. Out beyond the planets, there is this, it's not even in the plane of the galaxy. It's sort of like this shell of icy bodies that were just kind of part of the formation of the solar system, but they were too far out to really kind of get in with the main planet forming process. So that exists, it's out there. And will we ever be able to see it directly? It's pretty far out there and dim, but hopefully, something will get out there eventually. But yes, that is part of the solar system, is perhaps the most distant particle part of the solar system. And some of the comets that come our way that we haven't seen before, that aren't like the regular returning ones, are likely coming from the Oort cloud.
Okay. Oh, is the Oort cloud the same as the heliosphere? I was reading about like heliosphere, like protective barrier.
The heliosphere there's the heliopause, and that's about the point when the pressure from the solar wind hits the point where the interstellar medium kind of outweighs it. And the Voyager spacecraft has passed beyond that. So it is kind of outside. They call it technically leaving the solar system because it has passed beyond the heliopause. It's gone to the point where the density of stuff out there isn't from our sun, but it's from the interstellar medium. And this is not really related to that because it's not related to the difference in pressure from the sun versus interstellar medium. But it is technically part of the creation process that made the sun and the earth and the other elements in our solar system. So same parent collapse of dust and gas that formed our sun created that. It's just really distant leftover icy building blocks.
Nice. Oh, okay, cool. Thank you. I think it's amazing just how our solar system has these natural barrier. We're sort of in this bubble, so to speak.
Indeed, we are. Yes. And as a matter of fact, our solar system, a few others, are kind of in this region of the Milky Way galaxy that is not quite as dense as others. So going back billions of years, I don't have the number in front of me, but it's likely that there was a supernova explosion that kind of cleared out this area, or perhaps a series of them. And when you look at stellar nurseries, these supernova explosions sometimes can be the kick necessary to jumpstart the collapse of dust and gas to form new solar systems. So one star dies, more are born.
It's like starting.
But here we are in our solar system, and yes, our sun does kind of push out this interstellar medium, but it's not a protective shell. It's just a bubble. The protective shell is Earth's magnetic field. And let's hoping that doesn't go anywhere in the near future.
Right.
Is
So
that also like the magnetosphere? Is that the same? Is that what that is too? Or
Yes.
yeah, okay, all right.
We the power of Earth's magnetic field to protect us from the sun's radiation and also stuff in space. There was a gamma ray burst in a very distant galaxy, and the force of that was enough to actually push down on Earth's magnetic field. So
Oh, wow.
the universe is a pretty dangerous place, and it really wants you dead. I hate to say it, but it is Earth's magnetic field that has made it kind of safe to live on. If you take a look at our nearest celestial neighbor when it comes to stars, you look at Proxima Centauri. That is a red dwarf star, and red dwarfs, unlike our sun, they don't have quite the layers like we have the mantle and the core on Earth. These stars are small, and they churn and they mix so well that they can create these solar flares that completely strip atmospheres off planets. So when you hear that there's a planet in the habitable zone around a red dwarf, it all depends, because this, you may be getting just the right amount of normal heat, but these things are really quite dangerous when it comes to things like solar flares. So yeah, complex
Oh, wow.
relationship of planets and their host stars.
So like as the star ages, then is it like it would be like provided like an extra, or would there be like an extra level of danger for like the planets around it, right? Possibly.
Well, well, yes, eventually, come back in what, 3 billion years? I'm trying to get that right again.
I'm
When
setting
our
my
sun gets being
timer now.
Yeah,
Okay, all right.
Earth
Okay.
will actually
We'll
be
expand, that's
inside
right.
of the sun.
Yep.
Where you're sitting now will be in the outer
Yes.
area of our sun. But things like red dwarfs, they burn their fuel so slowly that some of the smallest ones could burn for longer than the current life of the universe. We're talking, 14 billion years of just slowly being stars.
Just
We're in
chilling,
the one
being
we're at.
Just doing it. Yeah.
just
I mean, what better way?
sipping rather than gulping.
Yeah. It's a
So
nice little sipper for the drink.
I was going to, something that Nick had raised in Georgia about these, kind of asteroids and what was in them, life or other, but, there are
Superman.
companies, Superman, yes, companies that
Yes,
are
Superman.
starting up to mine asteroids to go out, and because they have valuable resources that, or at least commodities that on Earth we value.
Oh, can we
And
make
so if you go-
smartphones with them?
Well, potentially, but if you go mining and there's an accident, can you change a trajectory now that wouldn't give us enough time? That makes sense?
Everything kind of makes sense, and if you want to be
And does
like
it?
blowing things up on the surface of an asteroid to get a few rocks, good on. I would not want to be the insurance company on that particular situation, but it is.
Is that planned for? That's my question. Like the tabletop, are you guys like Company X is mining there was an asteroid that was 24 karat gold or whatever. So someone decides to go up, send some rovers up there, land,
Well,
starts drilling into it.
Was that
and-
part of the Don't Look Up?
They had
That was kind of part
of it. Yeah,
Yeah.
they did have some sort of
And
mining,
also-
but that was
Also, I think that was in the For All,
for all of mankind. They had it right.
Yeah.
They captured an asteroid that had, I forget what, kind of
Yeah.
rare earth element in it, but it could create a potential hazard, right? I mean, that's
Well, mining in general, I think, would have some kind of side effects of.
I mean, if you push the asteroid
Yeah.
now into the path of Earth
Wow.
unintentionally,
Somebody uses poor judgment when it comes to making lots of money.
no one ever does that.
never in history. Well, it's kind of funny because one of the joys I have in life is to read some stuff in the news that I look at and just shake my head ruefully. And you never know where this stuff originally comes from. But at the launch of the Psyche spacecraft, which is on its way to this asteroid, it's kind of cool because it is sort of what the core of a planet should be like. So this is like the metal core of a planet, that planetesimal planetary body that kind of got blown apart. We have a mission headed to that. And for reasons I can't understand, someone somewhere threw out a monetary figure for how much that metal would be. It's in the like hundreds to thousands of quadrillions of dollars of iron, nickel, gold, platinum.
Yeah.
And it's
Yeah, so a couple companies started to mine asteroids, I think. I think one might be defunct now, but it was, that was it didn't work out so well. No, but that was their plan to go up there and harvest.
Maybe somebody was being purely cynical and saying, listen, don't cancel this project. Look how much money you could get. That kind of thing.
Yeah.
I don't know.
The
We
possibilities.
can bring the asteroid into our orbit and then mine it for forever.
We
right?
have
So that was-
the asteroid crash into Earth.
That's right. Yeah. In the ocean, you can guide it into the ocean now. And in the 12 countries that get the tsunami, hey, you know what? But we got now a giant hunk of rare earth metal kind of here, right? So can we...
Not even Earth metal. Some other
Well,
planet metal.
getting it in is going to be kind of tough. I mean, these things are 2.5, 3.5 times more than Earth's distance from the sun. So it's a bit of a, the idea of these asteroids being a gold mine is kind of fun. It's like I wouldn't mind getting a big hunk of that, but it's just scientifically the engineering aspect of it. I can't. I don't think we're there yet, but it is an idea. And the idea of let's take a look at the moon. That's easier to get to, and it's not going to run into the Earth.
Right.
So maybe that would be it. I think that would be it.
First target.
First target. Let's aim low. Let's make it easy.
It's made of cheese, though.
Yeah, it's just cheese.
Right? Wallace and
Camembert.
Wallace and Gromit have verified that. So
That's right.
So, quick question.
I love it. Yeah.
For your scenario tables,
Yeah.
do you
Tabletop
tabletops?
RGPs.
Yes. Is it essentially just like a game for everyone, but like a more serious version of it? Like, are you guys just out
Are
there
you guys
drinking
rolling
beers
dice?
and
Are you like, you need a
Are you
14?
can I join? Is what I'm really
Or
asking.
are you asking, is this something that we could all play? Like on our own? Like,
I brought my 20-sided die, but did not need it.
You needed the 100-sided one.
Will it hit DC or Chicago? Come on.
Oh, and I tell you, I roll a 1 no matter what I do. But there's one. It was very interesting, the fact that you don't control the physics. You don't control what's going to happen. You control how you respond to it policy wise, and that's really kind of the important thing. Is that, there's our limited ability to change the solar system is our ability to do that is really small. Our ability to do something with politics, well, that's harder, but it could be done. Basically, getting past that. I think though that if I'm to speculate about the future, I think our ability to track these things is just going to get phenomenally better. There was
If funding stays.
Funding stays, but there is one that in June of 2028, NASA is planning to launch, and it all looks good, for something called NEO Surveyor, and this is going to be the first space-based telescope that was originally designed specifically to make discovering and categorizing these potentially hazardous objects. So suddenly we've got capabilities that we never had to really identify a potential impact threat. I think that's brilliant that we're actually making that investment, that it's being built, that it's planning for launch in about 2 years from now. There was something called, I'm completely drawing a blank, but that's life with me.
Yeah. No.
There was a previous mission that did look for these things as well, but it wasn't designed for that. It was kind of like, oh, this telescope has lost its infrared capabilities. Well, maybe we can use it for looking for asteroids. And it really did have a phenomenal boost to identifying them. But again, it was sort of off-market usage, and this one will be specifically designed to make that an observing powerhouse. So what we'll find from this, the science we'll get will be amazing, but I think it's going to be a genuine, I don't want to say relief, but going to bed 3 years from now realizing that we really do have a good handle on this.
Right.
But we have something now that is going to be amazingly beneficial, and that is the Vera Rubin telescope. This thing is taking the entire sky about every 3 nights in high resolution, high def, and it's unlike other telescopes, which kind of home in on specific objects. Okay, we're going to spend 3 nights. We're going to observe this particular distant star system. Now, this is creating sort of a movie of the universe. It's showing how things change over time, from supernovae, gamma ray bursts, to anything going across the sky that could be a near-Earth object. So this is up. It's running. It's making phenomenal observations. The data is a fire hose of content.
Is that something
And
like
in
we
that-
can see, or is it just for you guys?
No, absolutely. You can take a look at the data.
$1.
We'll have to put the link to that. in the
Yeah,
show
we
notes.
can. Yep. And a dash
it's
will be
actually-
that too. The dark, they'll put that up.
Yeah, please do. Yeah, but it's actually being kind of run by something called NORLab, which is the NSF-funded ground-based observatories, and named after Vera Rubin, who is credited with as one of the discoverers of dark matter. Funny thing, I actually got a butt dial from her back in the day.
Oh, wow.
Yay!
That's awesome.
My phone number was up on a website, and she was trying to reach someone, and goes, "Hello, this is Vera Rubin. Can I speak to you?"
Oh,
And I'm
my
like,
gosh.
"Okay, totally geeked out on the phone."
You're like, wait, just
But
a
it-
minute.
Yeah. Charles, the
But
question.
it's
Go ahead.
yeah, go ahead.
No, or go finish your thought. I can.
Well, I was just saying the Rubin Observatory is in Chile. It's at a site with a number of other astronomical observatories. So it is one of the best sites on Earth. The atmosphere is dry, it's clear, it has Pacific Ocean on one side and the Andes. So what you're looking at is really, if you want to look and see the entire universe and see if there are these near Earth objects, track them, categorize them, as well as any transient thing happening in space, this is going to be, really, I think it's just going to change observational astronomy in the years coming, because it will bring to astronomers and people who are just fascinated in it the ability to look at data in a way that we've never been able to do. This is the universe as it's changing as we're observing it, and we can finally take a look at that data. So yeah, anything going
Wow.
across the sky, it will see it.
Hell yeah.
So I was going to ask this follow up. What time frame do we need to take action? You could say 100 years out, great, but what's the closest time frame? Are we talking
The least amount of time?
years?
That you
what
could
are
actually
we
do
that we can
something about
actually
it.
mount a defense, realistic defense, not Hollywood style. It can be
Yeah,
arranged. You don't got to pin it down like to the day.
I really wish I had something better, but again, the longer the better
Yeah.
is always great. But if
Yeah.
we have a heavy lift vehicle that can get first something to get out there and take a look at it, it's really remarkable. I will say, for the commercial launch companies that are out there, the amount of launches they can do in a year is phenomenal. Psyche, the spacecraft, was launched on a Falcon Heavy. And again, it's putting it out in that direction. But here's the thing. It's not a direct trip. This has to do these gravity boosts. It has to come back around the Earth, make a couple of passes till it finally gets to where it's going to need to be. So this was launched Psyche's
Interesting.
launched 2024. It's going to get there 2028.
Okay. So that's 4 years
Let's
right
say-
there. Yeah.
Yeah, design, build,
Right,
unless
right.
you really have something like, let's say, the SLS, the Space Launch System that's going to launch the Artemis 2. If you get something that heavy, yeah, you can sort of power through some of it a bit. But
we don't have
it
nothing
takes
just
a while
sitting
to
there
build.
waiting, like just in case, like
No.
break glass just in case you're going. Like, so, okay.
So like a year.
But you gotta think,
advance,
if we had
can't
one
do
in
anything.
production,
Yeah, wow.
not a lot you can do.
Right.
There are also speculations of things like if you had ground-based lasers, and you
Right. I was going to
if they were making it pass by Earth before it came around again,
Oh,
And
laser.
interactive
Just-
weapons. Yeah.
Oh,
or just hitting
Yeah.
it, and the
Yeah.
heat from this would
Would
cause
move
it
a little
to
bit.
outgas.
Yeah.
Just a nudge at the right amount of time is fantastic.
And I was going to, this brings me to, I do have my list and I want to get to it because I like going through it. But
Okay.
one of my favorite, we talked about this, is the Starship Troopers, and especially the movie, not the novel, but the movie, 97 movie. And the bugs
Love it.
are accused of launching the asteroid which hits Earth from other halfway across the galaxy. It was not close, several solar systems away. And during our discussion, I just kept thinking about it, and it was churning in my head that to launch a rock and hit Earth, travel through the universe and
love
hit
that
Earth
movie
is
so
is
much.
and then the conspiracy theory was that we actually allowed that to hit Earth because we wanted to go to war, right? Because it was a political it was a military satire.
right.
Are you leaning that way? Are you buying into the conspiracy?
I absolutely 100%. If you can send Starship Troopers off to another planet, but you can't push an asteroid, oh please, yeah. It was
So they would have should have seen that.
totally a
Yeah.
false flag.
So Buenos Aires city killer asteroid probably we should have seen. We would have deflected and moved along. My other favorite theory is that it hit when I forget her name changed the flight plan of the ship, and that hit the asteroid that sheared off the communications deck. That tipped it enough to actually hit Earth. So that the bugs actually didn't. It was actually that was the tip. So all right. So I'm conspiracy theorying now.
I like that. No, I'm 100% behind you on that. I was like, oh, come on.
I think we've
Suspension of disbelief
established
is
that.
one thing.
Yeah, we all have. I think we all have impeccable taste in movies. I think we've discovered this about this too. So we all love Starship Troopers. Come on now.
I'm a segue into my list, which I always
just-
promise. And
yeah, you're just-
because I did.
Okay.
I put this together, but I try to go back and find the oldest references to some of these kind of ideas in fictional literature, and I'm always surprised, like sometime how far you go back in
Greek mythology.
the state of knowledge. And it was not no
Really?
or maybe that didn't come up on my list.
Oh,
but
so you're just wrong. Okay,
or
got it.
maybe I am wrong. But I have 1833, The Comet by Oliver Wendell Holmes Sr. And this was a poem depicting the terror and pain caused by an approaching comet. So that was coming because this was still a time where these kind of astrological events were still, people didn't understand them fully, and there was some paranoia. And it was in 1839, The Conversation of Eros and Charmian by Edgar Allan Poe. And this was a short story told from the afterlife by two souls recounting the destruction of Earth by a comet.
What was the name
And
of the story again?
The Conversation of Eros and Charmian.
Oh, okay. Have to look that one up in my
Yeah.
my doorstop that has all of his stuff in it. Yeah, it's great.
1893.
Yeah. All right.
La Fin du Monde, The End of the World by Camille Flammarion, translated to English in 1894 as Omega, The Last Days of the World. And actually it was interesting because he was a scientist. He was a French astronomer and wrote about a comet strike that hits Earth and the physical consequences and humanity, psychological and philosophical response to the certain extinction. It was later adopted into a movie in 1931.
It's also a really good beer.
And it's a very good beer. That's right.
Just had
19,
to throw that in.
Yep.
1887, you had The Star by H.G. Wells. And that was about a rogue star enters the solar system, causing catastrophic tidal waves, earthquakes, climate disruption. And then 1920, you had The Comet by W.E.B. Du Bois. It was a short story about a comet striking New York. Remarkable in its time because it was about a black protagonist and using the catastrophe as a lens for examining race in America, because he was like one of the last people alive and interacting with people. So really good. And so then you go on 1933 when worlds collide. That was a collision course with Earth and a rogue planet. You had Lucifer Hammer in 77, Larry Niven and Jerry Pernow. And by the same two authors, Footfall. And these were really a lot of science, really good science about one was about a comet impact on Earth, and the other one was about an aliens use asteroids to modify Earth's environment so that they can take over. So you use this dual purpose, one, the catastrophic wiping out humanity, and then landing and terraforming Earth, or extraterrestrial forming. I don't know what you would call it. And then Hammer of God by Arthur Clarke. And so that was one of the most scientifically serious kind of treatments of planetary defense, and something that Clarke worked out, kind of actual mechanics and things like that. So, and then you go into film and TV, early 1900s, you had The Comet. There's a lot of stories called The Comet. They weren't very creative with these things.
Just makes it easier.
It's just, yeah.
But accurate.
No.
That's a nice
Yeah,
thing.
that was,
You know what you're getting into.
It was by the Edison Film Company. It was one of the first films depicting an apocalyptic comic impact. So that was released during the 1910 appearance of Halley's Comet. You had 1916.
Oh, good good story on that too.
Oh.
Is that there was quite there was a hysteria on Earth because of the 1910 Halley's Comet, that spectroscopic observations of its tail detected cyanogen gas, which is related to cyanide and arsenic in the comet's tail, and that created a panic on Earth. That as Earth passed through the tail of this comet, it would have caused death. You know, snuffing out of all life on the planet was one of the sensational things. I think there were socialites in New York who actually had a comet party or something like that. But yeah, that was that was an
People were
interesting.
terrified.
Yeah.
No, so in 1916, Verdens Undergang, Danish film. I know my Danish isn't as good as my English, but
Can you give it to me one more time?
it was known in English as the end of the world. And so that was the same kind of idea about comet, Halley's Comet. When Worlds Collide, the kind of film adaptation. 1979, we mentioned this one, Meteor, Sean Connery, Henry Fonda. And the U.S. and Soviet, they have been secretly building nuclear kind of platforms in space. And now they have to admit that they were doing this to kind of take out a meteor. 97, jumping ahead, the Starship Troopers. And then
throw that in
98 was a banner year for planetary kind of defense with both Deep Impact and Armageddon, and both were scientifically flawed. Maybe Deep Impact might have had a little more scientific grounding, but
Oh, I thought you were going to say
it
scientific
didn't have
flawed.
it didn't have like, you know, both were just cinematic.
Ooh, that's a new word.
Some were blockbusters.
Wow.
And it's interesting. Deep Impact had Robert Duvall, who recently passed away, and Armageddon had Bruce Willis as their kind of their lead stars.
R.I.P. Bruce Willis.
And then you had, then we go through Seeking a Friend for the End of the World, more focusing, I think Charles had brought this up, on humanity in the face of kind of the final weeks leading up to the impact. Greenland in 2020, Don't Look Up in 21, and Moonfall in 2022. And I haven't seen that one. The moon is knocked out of orbit and falling towards Earth. Nonsense, tons of hand wavium, but kind of interesting about what would happen if a big, a moon-sized thing hit Earth. I mean, it'd probably be the end of us all. I don't know. Is that true? Am I?
Yeah, no, that's what you call a non-survivable event.
So can we shoot a nuke at that?
I do have a funny personal story on Deep Impact. This has to do with the world of science communication. But Seth Shostak, who works at the SETI Institute, he's an astronomer there, had been involved in the search for extraterrestrial intelligence way back in his career. He was hired as the science advisor for Deep Impact. And he's looking over the script, and they asked him specifically, does this sound right? Would a scientist say, excuse me, doctor, but recent calculations based on this particular trajectory shows a bolide with a 94% chance of intercept at this particular point? And Seth responded to the producer and said, no, they would say, Bob, there's a goddamn big rock headed this way. Unfortunately, Seth's edit did not make it in the movie, but I still love it.
Yes.
They missed
I think
it.
people
They
always
missed out
think,
on that.
scientists speak, and it's usually cut to the point. It's,
yeah.
And I missed, Nick, I didn't leave you out because I like to mention video games, but I had two on my list.
What do you have?
1979. Asteroids?
Yep.
Oh, there you go. Yes, of course.
There went my lunch money.
Another one I didn't know was Planetary Annihilation, where it's a strategy
What year was
game
that?
where you players crash moons and planets into each other's as weapons. And it kind of Project Thor was used, or the rods of God extraterrestrial weapon, and that was kind of inspiration
What
for the
year was
game.
that?
And that was 2016. So
Oh, okay.
pretty recent. So
Wow.
I didn't
I
know
don't know
Nick
that one.
and play that. And just the rods of God, that was the idea that you could use telephone pole size tungsten rods, put them in space, and then drop them and just use gravity to generate kinetic impact enough to destroy a city. And this was a real, I think the Navy in was it the 60s? Actually, with Jerry Purnell, who was the author of co-author of Footfall, and First Hammer kind of was developing, he's a Navy officer, was developing this as a technology, as a kind of a weapon.
As a real
As a real weapon, yeah. A lot of problems. It's hard to get that much tungsten up into space.
It worked, so it worked as fiction,
It's
but
probably
not as
cheaper
real.
not to do that, but
right.
the science is legitimate.
Yeah.
But like
You
the
see
idea.
impact.
Yeah, no, right.
Yeah.
I mean, the
Yeah.
targeting is a little, because if you're in a major conflict, you got to wait for Earth to rotate around to drop this thing. So you're like,
The planning
we're
behind
going to be
it.
there.
I'm
We're
all
going to
for
do
it.
something. We're going to do
now.
If someone wants to do that, I think it should be acceptable.
Someone goes to the bathroom and forgets to push the button. Oh, man, that's another,
So
But yeah.
I wanted to change the subject if
Oh,
it's appropriate at this point.
I don't, sure.
I wanted to ask you more about science communication and how you ended up in this field. And we try to bring in science here on our podcast, and sometimes we're much more successful.
Wait, we have
You,
to.
science is
times.
we bring in the science.
But
Go ahead,
I'm
Charles.
so glad you asked that, because I was also curious too. I think, like, what a cool job. To be able to explain science to people.
And it's fun too. I really enjoy it. It's a long story, and I could never recreate my career even if I tried. But it started way back when, in the 1970s. I was always interested in geology, and my grandparents lived right in the middle of the anthracite region of Pennsylvania. So from a young lad, I was out there picking up fossils of Pterophytes and Phycopterus, and you pick up any piece of shale, it's just packed full of fossils, and I was fascinated by this. So I did undergraduate at Dickinson and did all things Spanish and geology. But one of the field trips we took was to a strip mine outside of Shamokin, Pennsylvania, where they removed the top layer and they created this gorgeous anticline, this folded bit of rock after they stripped the coal off that was plunging down into the water. And it looked like the back of a whale, so they called it the humpback anticline. But along the walls were siderite nodules, there were tree trunks, and it was just packed full of this. That and washers and cars that people drove out there to, ditch and shoot guns at. But I thought it was really amazing. So I was working as a lowly editor indexer at the American Geological Institute. They had a magazine called Earth Science. And I flippantly said, boy, I'd love to write for that someday. And they said, well, give it a shot. So I went back out to the whale-black anticline, took some pictures, wrote a few things, and by God, they published it. I had no gobsmacked.
Awesome.
And I said, oh, I like this a lot better. So went in and got a degree in communications degree at American University and got lucky. I think my passion for science is what allowed me to convince people whether I was truly worthy or not, that I would be a great publicist for geophysics. And it was kind of downhill from there. Did a lot of work in engineering, but what really took me down this astronomy path was the National Radio Astronomy Observatory was looking for a public information officer. So I had the background in communication and I had the background in engineering. And it's like, well, that's a nice combination. Sure, come out here and do it. And it was fantastic. That's really where I think I learned virtually everything I know about the universe, because every day it was like taking a small course in planet formation or how stars form or what is the nature of these high velocity clouds that are smacking into the plane of the Milky Way galaxy, forming new stars. And let's look at the back of the cosmic microwave background radiation. How can we detect that with satellites? So every morning it's like spring in my step, ready to learn more about it. And it got me where I am. So it was more of a right place, right time, and just unquenchable desire to not shut up about it when I learned something. It's like, my parents had enough, please stop.
Yeah.
But it taught me that if you can say something interesting about science and make it so approachable that there's no jargon necessary, it captivates a lot of people. And it's been a blast.
Hell yeah.
Yeah. But I think, especially this time, being a scientist, trying to do this and communicate and have fun with it. And we bring in a lot of pop culture, as George is saying. We get off track because it is fun. And yet we have fun talking about conspiracies of Starship Troopers. But I think the other thing I think what's missing a lot right now in this period of time is people's curiosity. And I think that's something that, as a communication science communicator, how do you see that going and getting that across to people to be curious about their world? I think that feels like that's changing a little bit.
I got to say, it seems to get beaten out of people at a certain age. Boy, if you go to these science festivals, they are so targeted at the very young.
Mm-hmm.
And anyone who's middle school or older, they're set aside in this participatory role. You have to supervise, you're a chaperone, but the hands-on things really aren't for you. And that's a problem. So you and I, we met at the science fiction convention.
We did, MarsCon.
And the amount of people who really love science but don't have degrees in science, this is a place where it's like, okay, let's talk about how it's pop culture. If you go to something like Dragon Con, 85,000 of your closest friends packed together with no deodorant, but they get around, I think they get around 12,000 butts in the seats for the science part only.
Yeah.
So self-promote, but it's not really a thing yet. But I have the idea and have been pitching and am starting to build a little momentum for a fandom convention for science and engineering. So it's let's get people involved, having a good time. Let's have all the fun stuff like the dances and the parties and
Right.
But science is always like, oh, the science track. You're down that hallway to the left, go behind the water
basement.
cooler, down in the basement.
Yes.
Yeah. And let's put it on the main stage. And I think anyone who just wants to have fun with it and learn, if you go to a science conference, it's great stuff, but it's really hard to unpack it all. So let's unpack it.
Especially if you're coming at it. So I focus, a lot of stuff I do, my thing was to focus on adult science, and I have a story and I'm not going to tell it, but I realized, like you're just saying, Charles, that adults, their science knowledge is low, but and then their curiosity can hover. And then you got people whose curiosity is high, but then they feel shy about getting into and talking about science.
Well, yeah, it's
I don't know.
intimidating.
It's like, I don't know anything about science.
And it's kind of...
You and I have talked to people about like science stuff, and they're like, it's just so intimidating. But coming to our podcast, they're like, oh, you guys make it easier to compose and like
think about it and ask questions and get involved. And I think you're right. I think it would be nice to...
I think that there is an issue with scientists in general, like specifically you, Joe. No, I'm kidding. But getting so high up in your field and you're basically just talking to each other about, there is a lot of lingo. There is a lot of, things that other people wouldn't understand. And you're in that world, but you don't think, oh, maybe I should be letting other people that aren't here know about this. And so the whole idea of communicating those kind of ideas and thoughts, that's just so important. You know what I mean?
Yeah, and it's hard. Even talking about scientists communicating with non-scientists, but even within disciplines of science, the jargon is so steeped that it's sometimes hard to communicate with other scientists, just in other disciplines. So biologists, which I'm a cell biologist and a physicist, their terminology and their jargon is so off that it doesn't work. It's really nice to see programs at the undergrad, graduate level start to have co-sponsors where your PIs, your principal investigator, your boss, your mentor one's from biology, one's from physical science, chemistry.
And I think
that way, then you start to develop new language to communicate. But it's really not even, it's within the science community, and then it's even harder than to go out because, you're at some point and you're just used to talking. It's like texting now with the teenager. And
if you don't know it, you're not
That's right. Yeah. So that's kind of it.
It's really interesting, too. One thing I've also noticed, if you go to, let's say you're an astronomer, you've got your PhD, you know your stuff, you go to the American Astronomical Society meeting, your specialty may be in, let's say supernovas. You walk into a session on, let's say, pulsar timing arrays. You're lost. You can't understand a thing. You've got a PhD in astronomy. You're in astronomy talk, and the language that's being used is impenetrable. So that's the problem. Is precision is so important in science, but precision is the enemy of understanding.
Yes.
Right.
More precise, the fewer people you're talking to. So how do you beat that? Well, just practice.
Right. And figuring out what is the point? What is the needed thing to be said? And we went
I've got a question. I got a question for anybody sitting around the table. What is the coolest thing you have ever heard about the universe? Something that you read or heard or saw. What's one thing you were like, okay, that is really cool? Can you name something that just blew your mind when you heard about it?
I'm going to start off. I absolutely loved learning about supernovas when I was younger. And just space in general has always been a, overshadowing thing that I love reading about. So that's why, like, talking to you right now is just like it's one of the higher points for me right now. But just the idea of a star coming to its death and fully exploding the rest of its energy out has always been so fascinating to me. What about you?
I had, What? So like, it doesn't even have to be astronomy. Is there something about the natural world science that you're like, wow, that's really cool. I like that.
I don't think I could think of like a specific thing that makes sense right now, but
our guest is asking the host the questions now.
We did go.
I love it.
We did go see Neil. Oh my God.
DeGrasse.
Yes. And it was at like Chicago Theater, and it was so cool. And we took our two sons, and one was very young and he did fall asleep, but
I fall asleep in his talks too.
But our older son was pretty engaged about it. And I just remember that feeling, and this sounds horrible, but feeling very insignificant, like realizing how huge the universe is and how tiny we are, and just that perspective of it. But at the same time, something really cool about that too.
Well, there's a follow-on question that I can give, and I don't want to, if you want to answer that question initially, but when I'm talking to an audience, particularly if I'm lucky enough to get to a school, I'll ask that question. And then I'll follow on and go, okay, if there's one thing you ever really wanted to know about space, you wanted to really know about it, what do you want to know? And you see like the sea of smiles and hands shoot up. And we have to capture that. So again, starting with what did you learn that was really cool? If you could know one thing about the universe that would just be cool, what would you like to know? And I would always be sure to at least try and answer in some way those questions, or say, wow, we don't know, but wouldn't it be cool if you found that out?
Right.
Yeah.
Were you going to say something, Mary?
Mary.
Oh, gosh, so many. But one of the things that I think about is, are we alone in the universe? I always like to think about those things. Talking about Neil deGrasse Tyson, when he did the Cosmos, redid the Cosmos series, and the part we was talking about the black holes, or people talking about different theories of what maybe lies on the other side of the black hole, and it may be that like forgive me if I get this wrong, but there might be another universe on the other side of that black hole. Like it could be like we are, like wherever we are at, we're on the, I don't know, like there could be like another universe on that. It's something fairly mundane. You get to the other side and like Neil deGrasse Tyson sitting in a parking lot. It could be this, who knows? But I
just came out on that too, which totally blew my mind when I read it too.
Oh, wow.
Yes. If you get to it, like, the very, very center of the black hole, this thing that it's like a point so dense that it has no shape and time doesn't exist, that just totally screws up a whole bunch of physics thoughts. But the new paper says, no, see, that's actually the wormhole to the other universe. So information isn't lost. We don't break the rules of physics. This is it. You look at it and go, it fits in with physics. And there's no reason to say it's impossible. No evidence to support it, but
there's a non-zero chance, possibly. Yeah,
that's right. Joe, prep my suit.
There's a non-zero chance.
That's right.
Yeah,
we gotta do it.
Give me my suit and dinner.
All right,
I'll jump.
We're coming up to the end of this, so we probably should wrap. Any last?
Virtually every topic in the scene.
I know. Yeah, right. We've done it all.
Okay. Well, I'm saving a question, but I did have a question about.
Wait to the end.
I waited very the
question. It seems a very weighty thing.
The other, and I'm unravel another universe. But I did want to ask about the telescopes that we use to monitor this activity. I know some of the telescopes are welcomed by the countries that are there, and some of them sometimes, like I'm thinking of in Hawaii, there was There are, and I wanted you to talk about that a little bit, about sometimes the telescopes are not wanted by the people that live there.
And I have a very direct relationship with that. I was working for the 30-meter telescope when they were selecting between Chile and Mauna Kea in Hawaii. It was, Hawaii is one of the best sites in the world to study the universe. It also is the most sacred point of this particular culture. So I will say there was a lot of weight put on astronomy, from the essentially forcing Hawaii to become part of the United States, to a long history of just colonialism and past observatories back in the day who would bulldoze over the pu'us, which were the cinder cones, or if there were shrines erected, oh well, we need to put another table, we'll just go through that. And now the idea is, let's work together, let's try and be as caring and cultural as possible to provide value. But it just doesn't, Hawaii doesn't look like it's on the table. Other countries, Chile thinks of it as it's an industry, and it's a heck of a lot better than another copper mine, and they love to have it there. It's another great spot. Spain, you've got Tenerife that has observatories there. It's still very well received. But even in the United States, continental in the United States, you have the National Optical Astronomy Observatory in the city of Mexico, but that's not it. Arizona.
Arizona.
Yeah, it is on land that is owned by one of the native tribes there, and the rules to get on it are very strict. And you really do try to be very sensitive about that and culturally aware that you are being allowed to do this. And even things like that mountain over there, don't take a picture of it. Okay, you can take a picture of everything else, but not that. So knowing that in advance is a huge help. But and you can, if you're interested in telescopes, go out and see one. There are so many that have great visitor center, from radio telescopes in West Virginia to, again, the ones in Arizona. They have visitors programs there. The ones in Chile have visitors programs. And it's
field trip to Chile.
Mind-blowing to see them in person. Really mind-blowing.
I'm sure.
That sounds awesome.
Yeah.
So kind of wrapping up, Charles, do you have any last thoughts? I mean, like you said, we've covered went down a lot of rabbit holes, but if you have a last kind of parting comment, we'll give you the final say.
Sure. Yeah. Final say is, all of this is because of public support and investment, and that's not a guarantee. The fact that something like trying to find an asteroid that might wipe out all life on Earth seems kind of silly, that you have to worry about funding being taken away from that so other people can get tax breaks on their second yacht. But really, everything we can do to really instill in people that this is really the best use you could ever have for your resources for the long term. Go science, and it's not cheap, but it pays for itself 1,000 times over.
Well, that's right. Your job is, God bless the science communicators, right? To be able to articulate why we have well-funded people on one side, and we also need someone. If you don't articulate, if science communicators don't articulate that point, then that vacuum gets filled by other people who have other ideas, I guess, or other,
Or agendas.
Agendas,
Cool. That's it. I take it as a responsibility and a privilege.
Well, thank you so much for being here with us
And
tonight.
I'd like to know, could you be on our Call a Friend?
Is that, the phone a friend? I swear, if I ever got a program, I would be dead. It's been a delight. You guys are great. We got to get together and have a nice glass of wine sometime.
We will. That'd be awesome.
For sure.
So you have me, Joe.
Yeah, I got Nick.
We've got Nick.
Georgia.
We got Georgia.
You got Mary.
We got Mary.
And we went down some space hole.
Look up. Stay curious. Stay
Bye-bye.
safe. We love y'all.